Hey everyone, today we're looking at notes over domain and range from a graph and increasing and decreasing intervals. So in part one, we're going to start with domain and range from a graph. So for each of the following, state the domain and range and interval notation. So this is just a refresher from Algebra 2, but we also do get a little bit more tricky of graphs this year. So on number one, let's just refresh. Domain deals with X, you read the graph from left to right. Range deals with Y, you read the graph from bottom to top. Okay, so let's start with domain. So for the domain, we're reading from left to right, and I usually like to have something like a toothpick or something kind of thin handy. So as I'm going left to right, notice there's no graph, no graph, no graph until bam, I hit the graph. Yes, it's an open circle, but I do hit the graph. Okay, so what is the X value there that I'm passing through, that my toothpick is crossing through, where I first hit the graph? Well, the X value there is -1, 2, 3. So -3 is where the graph starts, and because that's an open circle, remember for interval notation you use parentheses. Okay, and then I am, as I travel left to right, I hit the graph and I'm continuing to hit a piece of the graph. Notice my toothpick is like crossing through some piece of the graph until I get right here, and then bam, that's the last point where my toothpick hits graph, and then everything past that, there's no graph. Okay, so what is that X value where my toothpick is crossing through? There, that is 1, 2, 3, 4, X equals 4. So 4 is my last X value that graph uses, and that is a closed circle there. So I go ahead and use brackets. Okay, range. So for range, I read from bottom to top. So then I'm looking bottom to top. So I'm not hitting any graph with my toothpick until bam, right there, my toothpick is hitting graph. And what is the Y value that my toothpick is crossing through where I hit the graph? That Y value is, I believe, -1, 2, 3. So -3 is my starting value for my range as well. However, in this instance, since that bottom point is a closed circle, I'm gonna have a bracket, unlike the parentheses for the domain. Okay, so then as I proceed up, my toothpick is continuing to lay on top of some part of the graph until I get to bam, right there. That's the last part, because anywhere above that, my toothpick is no longer touching graph. So my highest point on my graph is, where do I cross through the y-axis? 1, 2, 3, 4, I believe. And in this case, that top point is an open circle, so parentheses for that dude. All right, let's press on to number 2. So number 2, domain, left to right. So I'm moving along left to right. All of a sudden, bam, what's that X value where I touch the graph? It's -2. Yes, I know there's not like an open closed circle definite point, but that is, it's part of the graph. It's not an open circle, so essentially you're going to say it's closed. It is a closed endpoint. So you say -2 with a bracket, and then my toothpick is hitting graph all the way until the end of the graph, and then those arrows indicate that it's going to continue to go on forever. So on the right side, I have no bound. That means I'm gonna go to infinity. And remember, when you have no bound, you go to either positive or negative infinity. Remember that infinity and negative infinity both get parentheses. Okay, so that's domain. How about range? How low and how high does this graph go? Well, I would say if I'm looking at the picture, I hit it right there. That's the first point I hit it. But I have to look at that endpoint and notice, oh wait, that's not an endpoint, that's an arrow. This arrow is gonna, yeah, it's going to the right, but it's also going down forever, forever, forever. So again, this graph is going down without bound. So there will never be a lowest Y value, because it's gonna go down forever. So that means negative infinity as far as range goes, and same for how high. So I'm definitely hitting graph. There's no like holes or open spaces anywhere. I'm always hitting a solid part of the graph, and then it's going to continue to go up forever. So again, increases to positive infinity without bound, and of course always negative and positive infinity get parentheses. Okay, so let's get to the really tricky guys. Okay, try to bear with me, and of course this is why we practice, so if you're just not getting it, don't worry, you're going to get it by the time we finish the assignment. So domain left to right. So as I travel left to right, I notice, okay, On the left side, I've got this arrow that's going to go on forever. So of course on the left, I have negative infinity because this is going to go forever. I have no leftmost endpoint. It goes forever without bound to the left. So negative infinity, we'll get a parentheses. And then I'm hitting graph, hitting graph, hitting graph. And I will hit graph until I get to this asymptote. And on this asymptote, yeah, I'm hitting the graph, kinda, not really, because that's an asymptote that I'm hitting, okay? So there will never be a place that this graph actually touches this vertical asymptote. So I can touch horizontal asymptotes, but I cannot touch vertical. So that means the graph stops at -1, 2, 3. So I cannot use the x value of -3, so I say it's not included, it's parentheses, not bracket. And then I'm going to start back up. This U isn't really 100% necessary. I prefer it instead of just putting commas in between. So I'll probably use U's, but you may also see like commas in between. So then actually this part of the graph, as I'm moving along, this part right here picks back up on the other side of -3. So I'm going to start with -3 for this piece. So again, let's refresh. This piece right here went from negative infinity to to -3 here on this asymptote. It got as close as it could to -3, never touched, never crossed. Okay, that's why it's parentheses. And then this piece right here goes, as I'm reading and I'm looking at which pieces go left to right. This is the leftmost, this is the middle, this is the rightmost. Okay, so then I go to this piece, and this piece is gonna get as close to -3 as possible on the x-axis as well, but it'll never touch. That's why we get parentheses, because vertical asymptotes we can't touch, we can't cross. Okay, and then this piece goes all the way until here. This piece stops right here at x equals 2. Agreed? So I would say, oh, let's stop that piece at 2, except I notice that this piece picks back up at 2, and this piece has a closed circle. So actually, even though this piece doesn't use the x value of 2, this piece does. So that means you don't need to say 2 because 2 ends up being used. So actually you go from 2 to infinity. So on this piece, you can almost say that the domain from here to here, if I were to drag my toothpick along from here to here, I'm always touching some part of the graph. Yeah, I stop touching this part and I start touching this part, but it's always, my toothpick is always touching some part of the graph. So I know this is a little confusing right here, but this actually just goes from -3 to positive infinity. There are no places, there are no gaps in between where we don't use an x value. I know this piece doesn't use it, but since this piece does, it counts, okay, more or less, if that kind of makes sense. And if not, we can clear it up in class, no worries, okay? So that's the domain. All right, how about the range? How low, how high, and are there any breaks, gaps, y values that aren't being used in between? Well, this one's, again, pretty tricky because you look at this piece and you think, oh, this is probably my lowest piece, but look at this piece too, don't be deceived. This piece, yes, it's going to the left, but it also goes down forever. Okay, so this piece right here alone is gonna use all of the y values because it's gonna go down forever, it's gonna go up forever, and it's gonna touch every single y value it's gonna use every single y value that's possible from negative infinity to positive infinity. And all we really care about is, does this graph, anywhere on the graph, any piece, use those y values? And it certainly does. So yes, I know there's like a gap here for these two pieces, but if you're looking, does any other piece of the graph use those values? Yeah, this graph does. So basically when you're giving the domain and the range, you're not really telling the reader where the breaks are. You are telling the reader which y values are utilized for this entire graph. And with the piecewise graphs, the ones that are in pieces, it is a little more difficult than these continuous graphs. So, but that's why we're gonna get lots of practice, don't worry. Okay, number 4. We have another graph with breaks in it. So that makes it hard, but we're gonna tackle it. So left to right for domain. Okay, on the left, I hit the graph, the first point, my toothpick hits the graph on the left is right here, okay, at x equals -1, 2, 3, 4, 5, 6. Yes, -6. And since that point there has a solid dot, you're going to use a bracket. Okay, and then you do not ever use, no point on the graph or no part of the graph uses the x value of -1, 2, 3, 4. Now, if there were like a random dot right here that was closed in, then you wouldn't have to put -4 right here. You would say, -4 is being used. X equals -4 is being used by this point up here, so you don't even need to put it here. But unfortunately, there's just an open circle not being used anywhere else on the graph, so you do have to state it here. So -4 isn't used, and then again, you can either put parentheses or the little union with, and then that graph picks back up right after -4. Again, we start back at -4 with a parentheses, and then we go all the way. We use all these x values until we get here, -2. Again, that's another situation with the parentheses, union with, that's the U stands for union with. And we pick back up right here on the other side. So that was the left side of this little open circle. On the right side, we pick back up at as close as we can get to -2 without touching it. And then we use all these x values until we get to, oh, you think there's a break at +2, but there's not. Does this ordered pair, right, or this point right here use the x value of -2? It sure does. There's a closed circle. If both of these were open, then you would have to put a +2 here with the parentheses and then pick back up at +2 and say infinity. But since that one's closed, you can just say that from -2 all the way to infinity, you use all of these x values. Think about it again with the toothpick. Okay, if I were to run my toothpick along from -2 to infinity, would my toothpick be running through some piece of the graph that has a closed circle at every single point in time? Yes, the answer is yes, it sure would. Okay, and again, we're gonna get lots of practice, but this is how it kind of works, okay? So then for range bottom to top, how low do we go? Wheel, 1, 2, 3, 4, 5, 6, 7, I believe. So -7, closed circle, so bracket, comma. When do we hit our first bump that we have to kind of test and see? Well, you have this open circle here, but look, my toothpick is hitting graph right here. So that open circle kind of gets nullified by, oh, I'm using a part of the graph, so I don't have to say anything here like, oh no, we don't use that y value. So keep going, keep going, keep going. Boom, I hit another open circle, but look on the other side, I am hitting graph with my toothpick here. So I don't need to include, or, well, actually I'm lying, because yes, you do need to stop at this y value of 1, because look, past it you don't use, there's a space here over the entire graph, there's a space. So yes, we will stop at 1 because there's a space past it. Okay, so we'll stop at 1. It will get a bracket. This doesn't really look like a -7 with the bracket. Let me kind of fix that. There we go. Okay, we'll stop at 1 with a bracket because you have a closed circle here. In this case, the closed circle trumps or overrides the open circle. So you'll put the 1 in a bracket here, union with, and then you don't pick back up and start using y values again until you hit, what is this, 3? Until you hit 3, and that's going to be a parentheses. And then from 3 on, I would always hit graph if this arrow were to extend. I would always hit a graph somewhere. It's going up, up, up forever. So 3 to infinity. All right, and then I added a special one here, number 5. So let's do that one real quick. Look at this situation. So if I had the line x equals 2, so this little red line right here, what would my domain be? Well, the only x value this graph ever uses is right here on this line. So your domain would just be the singular value of 2, and it's a bracket because it's included. Okay, and then what would my range be? How low, how high? Well, you guessed it, -infinity to +infinity. Because it goes down forever and up forever and uses every value in between. But when I'm looking left to right, I only use the x value of 2. Okay, so let's move on to increasing and decreasing intervals. Okay, so we will describe the intervals using the domain. In other words, the x values. Okay, we will flatten to the x-axis. I'll show you what I mean, don't worry. And then we'll mark all turning points, and sometimes it's not a turning point. Sometimes it's like a break. Okay, so and I'll show you. We'll mark all turning points or breaks. Okay, and then when we're reading the graph, we're gonna read like we read a book from left to right. Okay, we'll read from left to right. Increasing would be that we're going up. I'm sure you guessed it. We talked about it a little. Decreasing would be going down. And constant would mean that we're staying flat. Okay, so let's talk about what I mean. So first we're going to look at number 1 and number 2, and we're going to flatten to the x-axis. We're gonna mark all turning points or breaks. Okay, so I know there's not arrows here, but we know that this graph, it's showing you that it's going on forever. It doesn't always have arrows. Like when you graph in your graphing calculator, it doesn't give you the arrows, but you know that it means it's going on forever. Okay, so let's flatten this sucker and just talk about x values. So if I read this graph like I'm reading a book, left to right, okay, then no matter where I start, could be like way down here, no matter where, I'm always going up, 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 up until bam, I hit right here, and then I start to go what? I start to go down. So that would be marking your turning point. We don't have any breaks, it's a continuous graph. We're gonna mark this turning point. So we're gonna mark right there as a turning point because it was right there, bam, where I marked. So I'm gonna flatten it to the x-axis, and I'm gonna mark what is that x value. That x value there is 0. And I think you'll see that if I were to keep going forever, it'd go down forever, so there's no more turning points. So the only turning point or break I have on my x-axis is here at 0, and the rest stays constant, or not constant, but it does the same thing, okay, throughout the rest of it, except for right here is the only place it changes what it's doing. Okay, so this is negative infinity to the left, this is positive infinity to the right. Alrighty, so as I'm reading my graph left to right, what happens from negative infinity to this turning point here? I'm going up. So what does that mean? I am increasing. So I put a plus. And then from my turning point on, I'm going down. So I'm going to put a minus. That's a decreasing section. So now when I list it, it's going to be easier. Don't even look at the graph anymore. Cover it and just use your number line that you flattened. So your increasing sections are all the sections with a plus. Your decreasing sections are all the sections with a minus. And then when we get there and we have them, we'll list those with a C. So our sections with plus go from negative infinity to 0. And for these, you will always use parentheses. Okay, always, always, always. Because at that turning point, you're neither increasing or decreasing. Okay, so we will always use parentheses for these. So you might want to always, can you all see that? Always use parentheses for increasing, decreasing, constant. Okay, so then for decreasing, we go from 0 to infinity. And there were no places of constant, so NA. All right, let's flatten number 2. So on number 2, I'm gonna draw my number line. Does it go forever? Yes, it's tiny, tiny, tiny. It's hard to see, but those are arrows, not dots, okay? So it does go forever, so read the graph like you read your book, left to right, and right here is where I'm going flat, but then all of a sudden I start going down. So I'm gonna come down here, flatten it, mark that turning point. That X value there is 0. And then I'm going down, 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 down. All of a sudden right here at this turning point, I start going flat. So what's the X value of that turning point? 1, 2, 3, 4. Right here, I'm gonna mark it. And then I'm going to, above this, list exactly what was happening. I try not to do too many things at once to confuse myself. So from negative infinity to this turning point here, I was constant. From 0, x equals 0 to x equals 4, I was going down, negative. And then from x equals 4 to positive infinity, I was staying constant again. So now let's list it here. Increasing intervals, 0 to 4. So I kind of made this tight, didn't I? 0 to 4. Decreasing, What am I saying? That's a minus. I'm like going crazy here. I'm so sorry. There were no increasing intervals, were there? NA, no pluses. Decreasing interval was from 0 to 4. Constant intervals were from -infinity to 0. And again, remember, you can either put the U or a comma in between, and then 4 to infinity. Okay, we've got a little bit more. I know this is long. I'm sorry. Okay, number 3. Okay, let's flatten this down. Okay, so yes, this goes left forever, right forever, indicated by the arrows. If I'm reading left to right, it's doing the same thing until here. That's a turning point. And then also I'm going up, and then boom, I hit that turning point, and then all of a sudden I'm going down. Okay, so and then I go down forever. So let's list the x values of these turning points. That was x equals 1, and that was x equals 2. Okay, and then I'm going to read the graph left to right and say, okay, that was a down from left to right. That's a minus. This little section right here was an up. That's a plus. This little section was a down, a minus. Might want to mark your negative and positive infinities to help you fill this in. So my pluses were from 1 to 2. My minuses were from -infinity to 1, and also 2 to infinity. There were no constants in A. Okay, increasing on this one, decreasing. Probably making it kind of close. Okay, hold on, wait, are there arrows? Yes, okay, I'm just making sure. Those are tiny little arrows, so arrows on both ends of my little flattened. Okay, so I'm going down, down, down until I hit this. Let's mark it down here. That was x equals -1, 2, 3, 4. So that's -4. And then I'm flat, flat, flat until I hit this. That is x equals 0, and then I'm going up forever. So again, let's mark them. This was down, minus, this was constant, C, this was up, plus. Okay, let's list it here. Oh, that was -infinity, infinity. My plus goes from 0 to infinity. My minus goes from -infinity to -4, and my constant goes from -4 to 0. What are y'all thinking? Hopefully not too bad. Okay, let's tackle this monster. Okay, look at this end, not an arrow. Okay, I knew they would try to get us at some point right here. I'm gonna, how am I gonna do this? Okay, I'm gonna draw my line. This line, it does have an arrow. Notice this side has an arrow. This side, I'm just gonna start it with a dot. So what is the x value here where we start? Looks like the x value here is -5.5. Oof. And so, okay, and then of course off to infinity on the right. Okay, so looking at our graph, notice I'm going up, 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 bam, right here. I need to come down here and mark this tight area right here. What is that x value? -5. Okay, and then I'm going down and down, and then I need to come down here and mark that area where I turn around. That's -4. And then come up here, mark that area at -3 where I switch. And then I'm flat, 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 and mark this area where I switched. That was 1, +1 for the, I'm getting the x values real fast from the ordered pairs. And then I'm going down, down, down until I hit the x value of 2. So I'm gonna list that one. And then I go up forever, so no reason to mark anything else. Okay, so notice that when I'm marking anywhere I change directions within the graph. And I'm only putting the x values, because remember, that's what it said to do here. Okay, so I'm just kind of refreshing. So now let's go through and actually put our pluses, minuses, and C's. So from here to here, I'm going up. From here to here, I'm going down. From here to here, I'm going back up. Then I'm staying flat. Then I'm going down. And then I'm going back up. Let's list them. Increasing. So increasing from -5.5 to -5. I'll put commas because I don't think the U's will fit. And then again from -4 to -3. Remember, both are acceptable. And then 2 to infinity. Nice, right? And then decreasing. -5 to -4. And then 1 to 2. Remember, those are your minuses. And then, looks like that's just a +2. I don't know what happened there. And then constant, where are we? Just, oh wait, increasing. Oh no, I'm good. Okay, -3 to 1 for constant. We're good. Okay, so on this next one, to shorten this video, come to class. Let's, as soon as we get to class, let's type this in our calculators. Grab a calculator. You can explore with it if you want at home, and we'll do this one with the class. Sound good? See you soon.